Chapter 9. Using Operators in Scratch. Chapter Surf. Sensing blocks, working with operators, random blocks, repeating actions, mapping the stage, animation, making projects. We have learned how to program a sprite to perform actions and changing its appearance. We also learned how to use extensions to enhance the functionality provided by pen blocks. Let us now learn about using operators in Scratch. Sensing blocks. The sensing blocks are used to control the actions of the sprite when a specific condition is satisfied. These blocks are light blue colored. Most of the sensing blocks are reporter blocks and are used in combination with other blocks. Some of the sensing blocks are block description. Reports true if a sprite is touching specified sprite, edge or mouse pointer. Reports true if a specified key is pressed. Lets the sprite ask a question and stores the keyboard input in block. The question asked appears in a call-out on the screen. The script waits as the user types a response until the enter key is pressed or the check mark is ticked. Stores the response for a question asked, entered through the keyboard. Reports true if the sprite is touching the specified color. Measures the distance between the sprite and the current mouse pointer position and stores it in the block. Example. Let us learn the use of sensing blocks through an example where the sprite asks a question and displays the answer as input by the user. Step 1. Create a new project. Step 2. In the scripts area, create the stack of blocks as shown in the image. Step 3. Click the green flag button to execute the project. Step 4. When prompted with the question on the stage, type an answer in the text box that appears on the stage and press Enter key or click the tick mark in the text box. Working with operators. An operator is a symbol used to perform a certain task or carry out a specific process. For example, the sum operator, plus, denotes the process of addition. An operator is capable of manipulating a certain value called an operand. Different operators work with one or more operands. For example, the sum operator requires at least 2 values to process. Operators blocks. The operators blocks, light green colored, that let you use the various operators in Scratch. The mathematical blocks are round in shape, while the relational and logical operator blocks are pointed at both ends. These blocks can easily be placed in the value box of any other block. The common types of operators used in programming are mathematical operator blocks. Mathematical operators are used to perform arithmetic or mathematical calculations on numeric values. The table given below illustrates the common arithmetic operators. Block description adds the numbers present in the 2 text boxes. Subtracts the second number from the first number. Multiplies the numbers present in the 2 text boxes. Divides the first number by the second number. Relational operator blocks. Relational operators or comparison operators are used to compare 2 values or expressions. A relational operator evaluates the result as true or false. The common relational operators are described in the table below. Block description returns true if the first number is equal to the second number else returns false. Returns true if the first number is greater than the second number, else returns false. Returns true if the first number is less than the second number, else returns false. Example, let us use the operator blocks to display the product of two numbers. Step 1. Create a new project. Step 2. Delete the cat sprite and add the Devon sprite. Step 3. In the scripts area, create the stack of blocks as shown in the image. Step 4. Click the green flag button to execute the project. Example, let us use the operator blocks to check if a number entered by the user is greater than 100 or not. Step 1. Create a new project. Step 2. Delete the cat sprite and add the Devon sprite from the sprites library. Step 3. In the scripts area, create the stack of blocks as shown in the image. Step 4. Click the green flag button to execute the project. Step 5. Enter a number and check the result as displayed on the stage. Step 6. Click the stop button to stop the project. Random block. The random number generator is found in the operator category of the blocks palette. To use the block, simply drag it and place it inside another block. Remember that the random block is a reporter block and cannot be used by itself. It has to be placed inside another block. The block will randomly pick a number between and including the numbers used. The default settings will produce a random number between 1 to 10. Generating random numbers. We can generate a random number from a specified range by using the Pick Random 1 to 10 block from the operator blocks category. Example, Step 1. Place the blocks in the script area as shown in the image and change the values. Step 2. Click on the block and you will see the sprite speaking random numbers between 1 to 30. Changing location randomly. We can use the Pick Random 1 to 10 block to specify any random location of a sprite on the stage. Step 1. Adding Pick Random 1 to 10 block on the glide 1 seconds to x is to 0, y is to 0 block will randomly change the x and y coordinates of the sprite's position on the stage. Step 2. Drag and place the blocks in the scripts area to create the Scratch script as shown and execute it to observe the sprite randomly changing its location. Example, let us move the balloon fly all around the stage. You can use block along with other blocks. Step 1. Delete the cat sprite and add a sprite, balloon 1. Step 2. Create the stack of blocks as shown in the image. Repeating actions. While creating a project, we come across situations where a group of instructions need to be executed more than once. This repetition of instructions can be a fixed number of times or until a specified condition is met, or even indefinitely. If we write the same set of instructions for every repetition of the code, the program would become very lengthy and unmanageable. In Scratch, the control blocks are used to implement the repetition of the blocks in a project. Control blocks. The control blocks in Scratch 3.0 are golden brown colored. These blocks are used to control the execution of the script. Some frequently used control blocks are described in the table below. Block. Description. Pauses the execution of the script by the specified time in seconds. Repeats the enclosed stack of blocks for the specified number of times. Repeats the enclosed stack of blocks until the specified condition evaluates to true. Repeats the enclosed stack of instructions indefinitely till the stop button is clicked. Stops the execution of script of a sprite or scripts for all sprites or all loops currently in the project. Example, let us draw a circle on the stage. Recall that to draw a circle, we need to move and turn the sprite a specified number of times using the repeat block. Step 1. Create a new project. Step 2. In the sprite info pane, type 25 in the size box to reduce the size of the sprite. Step 3. In the scripts area, create the stack of blocks as shown in the image. Step 4. Click the green flag button to execute the project. Example, let us move the sprite on the stage from one edge to another until any key pressed on the keyboard using repeat until block. Step 1. Create a new project. Step 2. In the scripts area, create the stack of blocks as shown in the image. Step 3. Click the green flag button to execute the project. The cat sprite moves on the stage. Step 4. Press the any key on the keyboard to stop the project. Example, let us move butterflies on the stage from one edge to another using forever block. Step 1. Create a new project. Step 2. Add the jungle backdrop from the backdrops library. Step 3. Delete the cat sprite and add the butterfly 1 and butterfly 2 sprites from the sprites library. Step 4. Position the sprites. Step 5. In the scripts area, create the stack of blocks for each sprite as shown in the image. Step 6. Click the green flag button to execute the project. The butterflies start moving around on the stage. Step 7. Click the stop button to stop the project. Mapping the stage. The stage is the area in the Scratch window where sprites move and interact with each other in a project. The exact location of a sprite is important in some projects to create animations or stories. This is done by manipulating the position of the sprite on the stage. Let us learn how to do this. Coordinate system on stage. The location of a sprite on the stage is determined by a combination of two values called coordinates. The x-coordinate determines the horizontal location of the sprite, and the y-coordinate determines the vertical location of the sprite. The size of the stage is 480 pixels wide and 360 pixels tall. Thus, the x-coordinate can range from 240 to -240, and the y-coordinate can range from 180 to -180. The center of the stage has x-coordinate 0 and y-coordinate 0. The x and y coordinates of the current mouse position are displayed in the x and y text boxes respectively in the sprite info pane. The image displays the coordinate system of the stage. Moving sprite on the stage. While programming a sprite to move to precise locations on the stage, keep the following points in mind. A positive x-coordinate is on the right side of the center of the stage. A negative x-coordinate is on the left side of the center of the stage. A positive y-coordinate is on the top side of the center of the stage. A negative y-coordinate is on the bottom side of the center of the stage. Some blocks that are used to move a sprite on the stage precisely are described in the table below. Block description stores the current x-coordinate of the sprite on the stage. Stores the current y-coordinate of the sprite on the stage. Sets the x-coordinate of the sprite to a specified position. Sets the y-coordinate of the sprite to a specified position. Changes the x-coordinate of the sprite by a specified value. Changes the y-coordinate of the sprite by a specified value. Moves the sprite to the specified position on the stage. Moves the sprite smoothly from the current position on the stage to the specified position for the specified time in seconds. Example, let us use the above blocks to move the sprite on the stage and draw a rectangle. Step 1. Create a new project. Step 2. Set the size of the cat sprite to 50 in the size box in the sprite info pane. Step 3. In the scripts area, create the stack of blocks as shown in the image. Step 4. Click the green flag button to execute the project. The cat sprite moves on the stage and draws a rectangle. Animation. In traditional animation, images are drawn or painted by hand on transparent celluloid sheets to be photographed and exhibited on film. Each image differs from the others in minute detail. The images are then displayed at a fast speed to create the illusion of movement. Today, most animations are made with computer systems using multimedia software. The amazing and breathtaking visual effects that you see in science fiction movies and the cartoon films are examples of animation being used. Creating animation in Scratch. Animation in Scratch can be created using the various blocks that we have studied. The blocks that represent appearance, motion, position, and size can be used to create animation of moving objects. Example, let us create a simple animation in Scratch. We will animate the backdrop of the stage to change color. We will also animate some letters to animate by changing color and rotation. Step 1. Create a new project. Step 2. Delete the cat sprite. Step 3. Add the night city backdrop from the backdrops library. Step 4. From the letters category in the sprites library, add the letters of your name. Here, we took the block S, block C, block R, block A, block T, block C2, and block H letter sprites to spell Scratch. Step 5. Click the backdrop in the backdrop pane and in the scripts area, create the stack of blocks as shown in the image. Step 6. In the scripts area, create the stack of blocks for each letter as shown in the image. You can specify your own values. These values are just a sample. Step 7. Click the green flag button to execute the project. Making projects. Project 1. Let us create an animation of an ocean scene using different sprites. Step 1. Create a new project. Step 2. Delete the cat sprite. Step 3. Add the underwater one backdrop from the backdrops library. Step 4. Add the following sprites from the sprites library: Diver 2, Starfish, Shark and Jellyfish. Position the sprites. Step 5. Select each and in the sprite info pane, type between 25 to 50 in the size box to reduce the size of each sprite. Step 6. In the scripts area, create the stack of blocks for each sprite as shown in the images. Step 7. Click the green flag button to execute the project. Project 2. Let us create a project where two sprites are conversing with each other. Step 1. Create a new project. Step 2. Delete the cat sprite and add the Devon and Alex sprites from the sprites library. Step 3. Add the hall backdrop from the backdrops library. Step 4. Position the sprites as shown in the image. Step 5. In the scripts area, create the stack of blocks as shown in the image for the two sprites. Step 6. Click the green flag button to execute the project.